Hello, hello, hello. Welcome, everybody. Hello, welcome to the BT Ireland Innovation Centre and Partners Showcase 2022. My name's Adam Oliver. Thank you for humouring me by coming to the front here and filling the audience up. So it's my pleasure to welcome you today and also to do a quick introduction to the speakers. This presentation will take 20 minutes and then we're going to get you back out to the display stand. I'll also just take this point at the moment to say that if you haven't spotted, there's a number of QR codes around upstairs. If you scan that QR code on your phone camera, it will bring up details on your phone of, I think, called a wrap, which gives you details about each individual project, and also the ability to contact the people you meet at that project as well. So if you want to further ask them a question, you can just click on that and you can send them an email or contact. Okay? So without further ado, I'd like to introduce our first presenter, Victorious, and then we're going to be followed by Andrew, and we're going to talk about the Belfast Harbour project. Thank you very much. Thank you.
Welcome all. Hi. So, okay, so we're here to actually, first, a big thank you for all the setup, all the Belfast people, hosting us today. It's really brilliant. So a big thank you for that. There's few demos in the back, which is work out of BTIIC, the BTIIC Innovation Centre. So you'd have definitely a very interesting day. I'm here to present to you a piece of that work. We also had the stand outside, the very end of the corridor, so come and see us. If we don't have time for questions, which I doubt we will in these 20 minutes, please come and see us. We're going to have a fabulous time there, show you the real thing, demonstrate you the real value-added services. So I'm here to talk about them and how we're going to be using them in Belfast Harbour today. So the format of this talk is going to cover business rationale, vision, what is IoT value-added services, and bring them into the context of Belfast Harbour, and then I'll hand over to my colleague Andrew, who is working at Ulster University, to give us a high-level tour of the IoT VAS. So a little bit of a setting, IoT, Internet of Things, great deal of new technology, new horizons. It transforms the way we work, transforms the way we live. This works at our places of work, this works at home as well. Starts from the left-hand side, where we have all the sensors, all this machinery we put in the physical domains, collects data and gives us a real-time view of what's going on, where we want to monitor. And we go different levels into where we exactly show this data, and we drive value out of that data in the application domain. So we have sensors using some connectivity in the pink sort of layer, driving data into what we call BT Data Exchange, the BT IoT data platform, or that could be AWS or something else of choice of the customer. And from the data exchange, you drive the applications. What's different here to what used to be traditionally IoT is that you had an application and a bunch of dedicated sensors collecting data for that application, and you repeated that all the time for every, times n being the number of applications. There was a string connecting the sensors to the application. We want to cut this silo now by putting this layer of data platform in the middle, the data exchange. All the data comes into the data exchange, and then from there you drive applications which can use the dedicated sensors data, but other data collected by other sensors, and drive more richer kind of decision making out of that application. What we saw here is turned around 90 degrees. So again, the same kind of view, but the message I want to drive from here is that because of these applications and the richness of decision making, the richness of data, you can drive ecosystems. So you can drive different verticals. So you can have applications in the health domain, smart city, manufacturing, ports, we're going to talk a bit about today, etc. And the message I want to drive out of this one here is the complexity and the scalability, two key factors which human, if you use manual intervention, humans to manage this complexity, it doesn't scale up, it doesn't deliver. So we are looking for autonomics. We're looking at ways where we can get the systems, manage systems. We want to get rules, we want to get policies, we want to get intelligence into the system so it can manage itself. So we want to actually start implementing, introducing AI, machine learning, federated learning, all these new cutting-edge technologies which provide us automatic ways of the system start thinking like humans. And we want to start implementing all these self-X, as I call them, capabilities on the right-hand side, which is the IoT Autonomics vision. So self-configuration, self-healing, self-optimization, self-adaptation, which is all talking about the way of managing all this complexity and scalability across all these layers. How do we deliver this vision? This vision of autonomics gives rise to what we call value-added services. So there is pockets of value. As I just explained, the scalability complexity would need some kind of self-X capabilities to get injected into the systems for autonomy. So this is where the pocket of extra value is, above and beyond the data aggregation in the middle. And that's what we call value-added services. We slot that in as extra layer in the architecture. And there is two ways of looking at it. This management capability is about the applications and services, or about the devices and the sensors. So as you're scaling up the numbers of sensors you want to deploy, can you automate the way they deploy? Not as much as about you still need a human to nail it into the ground or on top of the pole. But really, what happens after that happens? Do you switch it on? Now it takes, anecdotally, we say it takes about 20 minutes to set up a sensor after you switch it on with a human, logging in and configuring and provisioning it. Can we automate that? That's why we call zero-touch onboarding. Andrew's going to talk about it. It's an example of managing sensors. But there is also extra value to be had by using analytics on top of the data. So as you're receiving the data from the data exchange into your applications, you can extract more insights out of, more value in the form of insights, extra information out of the data that you consume in the applications. That's another way of looking at value-added services. And also, those two pink boxes there allow us to introduce the idea of IoT SLAs, service level agreements. So the same kind of service, you can offer it at different classes. Something more fine-grained, which you charge a bit more, or coarse-grained, which you maybe not charge offer for free, for instance. So the idea of SLA management comes into the game as well, something that currently in the market doesn't show up very much. So it's a new area to be looked at very seriously. Here, we replace those pink boxes into finer grain value-added services that we have developed in BTIIC. With BTIIC, actually, I don't know if I explained well, it's a collaboration between BT Applied Research and Ulster University. Yeah, so in that kind of collaboration, 5 years now, we've been developing some of those valued services, and you can see here, what's going on. We call it Matrix, the platform where we build all those VAS within. It's a flexible and scalable platform. It's mountable of any kind of IoT data platform that we're going to use, that being AWS or BT Data Exchange. The applications here are offered as an open catalog, as a catalog next to your data platform of open capabilities. So the customer can come and pick and choose whichever they want, and without starting or stopping applications or data flows from the sensors, they can deploy them dynamically into the execution environment. So that's the unique selling point of our work. Also, they're highly configurable. You can actually inject new policies, change the rules on the fly. You don't need to start and stop anything. And that allows us, actually, all these features I'm just describing here, high level, are going to allow us to start talking about differential classes of service, this SLA idea I mentioned before. We have a unique opportunity to bring all these concepts from the lab to somewhere to a living environment. And that, for us, is Belfast Harbour. The first opportunity doing that, is Belfast Harbour. I'm not going to go through this information, just to give you an idea of how complex the environment is. In itself, it's not just an area of a unique authority, doing operations and managing itself. It's an ecosystem, bullet point 4, of businesses, like a industrial park, businesses, people living, it's like a mini smart city, really. And to make it even more complex, they don't want to keep it isolated. They want to actually bring down the walls and expand into the city as well, Belfast Smart City. So this has become a very complex ecosystem. So it is an ideal environment for us to bring this IoT platform into there, and the value-added services start thinking how we can manage and remove the human out of the equation and making things more autonomic. Give you a very quick example of how this can happen in two scenarios of privacy protection and health and safety monitoring. So in an environment like Belfast Harbour, you're going to have surveillance systems. tens of thousands of cameras to do surveillance monitoring, security monitoring. There will be a case where security staff are going to have those feeds coming to them so they can see everything. But there might be users and viewers of those streams that you need to cater for what they see in the stream, because you might be exposing private items in those feeds that you shouldn't be exposing, either because of GDPR guidelines or specific sensitivities. So in there, we have value-added services we're going to show you at the port if you come, which is about anonymization. So in the stream, we have intelligence which remove people's faces or car number plates. And anything else sensitive. And you can scale it up as far up as you want, really, in terms of one object being removed, two objects being removed, etc., depending on which user group you want to address. So this is the value-added services I talked about, extracting value from analyzing and doing analytics on the content. And the magic here is you partition the same content for different user groups. Bit of a more complex scenario is once you have these streams anonymized, so you don't show who is walking down the street, you might be, we are mandated to be looking for hazards. People not falling in the sea, they walk on the edge of the waterfront, or falling down and hurting themselves. Or if there are workers in the port, entering areas where there's gases that can trigger their asthma or some kind of breathing problems. So in that case, you can combine video streams to locate them, but also data from other sensors, gas sensors, and then you can string up more than just one anonymizing kind of capabilities to do a more complex scenario. And that's how we want to actually be using all those IoT value-added services. As I said before, it's a unique opportunity for us to drive commercialization value out of these concepts, and that's what it's offered to us, by going to a customer's venue and try to deploy these concepts. Keeping it brief, I'm now going to hand over to Andrew to give you a quick overview of what's going on with the particular ones we develop in BTIIC. Thank you.
Okay, thanks, Aris. So as Aris has explained, the main sort of overall platform for Matrix, I'm now going to dive into some of the value-added services and give you a rough idea of what we're looking to develop and what we are developing. And some of these demos are operating and working at the demo space, so please feel free to come down and talk to us after. So the first value-added service is easy device onboarding. So the problem there is you've got hundreds, if not thousands, of sensors, and as Aris indicated, that can take a lot of time to manually go in, configure, set them up, work out where the data is actually going to flow to and what it's going to connect to. So ideally, we want a solution that you simply plug it in and it just automatically gets detected, provisions a specific profile down to that device on what it should be collecting, where it should be sending its data, and how to present that data to the Matrix system, and then it just works. So it should be fully automated, fast, reliable, and scalable. So whenever the deployment goes ahead and the people are out on site, they're just connecting it and attaching it to the pole or the wall, etc., and it automatically works. And it's, the whole idea is about the scalability. So if we're scaling up tens of thousands of sensors, you don't want to be manually configuring all of them. And sort of leading on from that is this challenge of making sure that the authenticity and that the integrity of that device is as you deployed it from day one. So you can physically secure devices, put them in cages, lock them away, put them up high, etc. But even still, the model today is zero trust. So you shouldn't trust even the most trusted devices. You should always be checking and making sure that that device hasn't been compromised or changed in any way. So there might be malware got infected on it, and you need to actually get that off the network and repair it. Or some device has been connected that's trying to fake its identity and pretend to be a legitimate device. And how do we account for that? Or simply a bad actor has come along, found an exposed port and connected into it, for example. So remote attestation is a way of doing this. And we're working to develop a solution that allows us to, both at the time of onboarding, but also periodically as throughout the device's life cycle, can we verify and authenticate that device and check that it is a legitimate device and it hasn't been compromised. So we're looking at using characteristics to build up a fingerprint of the devices. So hash values, MAC ID, PCR values, and private key pairs. And that just builds up this fingerprint for the device that we can then recognize and determine has it been modified from what it originally was. And the idea is to make it lightweight and perform at a station as quickly as possible so that we can get that device removed and off the network before it starts infecting or spreading to the other sensors. And the key thing about what we're trying to develop is, again, to have basically no physical interaction with that device. So we don't need to send somebody out to the actual physical location to check the device or disconnect it and play about with it, etc. We want to be able to try and do all that testing and checking remotely. And that's where the remote attestation comes from. As ours indicated, so we got privacy protection, and we're looking at video feeds and how can we actually remove, say, people's faces. Potentially a camera might be able to view a mobile phone, and there could be sensitive data on that phone, for example, and even number plates, for example. And how can we remove those, but then when it comes to presenting that to the different types of users that may need to see the cameras, we can essentially reintroduce that removed data depending on the requirements or the privileges that user has. So we can, for example, the security staff, probably they will have access to the full live feed and be able to see everything, but there may be users of the system that you're not allowed to see people's faces, for example, or number plates. So we can present in different ways the different camera feeds. And also same technology can be applied to text documents to remove personally identifiable information like names, addresses, etc. And then health and safety analytics is another area we're looking at. So can we detect, using the video camera systems, that somebody is entering a hazardous area? So say they are walking underneath a container that's currently being lifted and moved. Can we get an alert? Can we detect that, get an alert out as quickly as possible to warn that person that they shouldn't be there and they should leave that area? And again, there's other examples such as if we detect a person that falls or an incident that happens, can we alert the emergency services and get them to respond as quickly as possible? And the SLAs come into that, and I'll get to that in the next slide. So with all these deployments of cameras and things, Iris talked about the BT data exchange. We need to build in the video side of that as well, so actually handling those streams and all the file storage. So there's a challenge that if you've got tens of thousands of cameras, how do you actually handle all that data at scale? Both not only pushing it, say, to the cloud, but also you might, for GDPR compliance, want to keep it on site at the edge. So we're looking to build a high availability storage platform that's based upon the Apache Cassandra to be able to store this data along with the metadata, and then be able to query that and pull analytics out of that and generate reports or visualizations to what the data is representing. And then self-healing networks is another area that we've been looking at. So whenever a device is detected as being infected, we want to essentially isolate that and get it off the network before it starts trying to attack other devices. So we've come up with an idea where we've got a green network where the devices are okay, they're testing as they should be, and everything is operating. We have a quarantine network, and there is a red box there. I don't think it's too visible, but that's where we can actually completely take it offline and just keep it totally isolated. So if a device gets detected that it's actually been, say, infected with malware and it starts trying to attack other devices, we can immediately pick that up and move it across to the quarantine network, where it is then isolated and can't start to spread. We will then perform tasks to sort of mitigate that and revert it back to being into a good state, but we won't just simply move it straight back into the good network. We will let it kind of test and see how it develops and make sure that it has been resolved properly. And once we have detected that, we can then redeploy it back out into the production network where it is approved again. And the whole idea there is just really trying to actually isolate these devices so that they don't start spreading and attacking the other devices on the network, which is a very common thing nowadays with IoT devices. And just to say, there's been a number of awards awarded to that over the last couple of years to the work that's been done there. And lastly, Iris talked briefly about SLAs, but if you saw from the diagram at the start there, we have all our value-added services, but on top of that, we want to apply different levels of SLAs. So those SLAs will depend on who the user is of the particular data and what they want to see. So for example, coming into Belfast Harbour, there maybe a cruise ship, and the passengers on that ship might expect to have Wi-Fi, access to tourist guides, and tours and things, possibly for free, maybe for a small fee, etc. But then the port staff will need different levels, so they will need more fine-grained detail as to what has been detected, what analytics are there, etc. And we can start to split that up and shape it into what requirements are needed for the various audiences of the data. And that is everything that I have. Obviously, we have the demo area, so I don't know if we have time for questions now, but feel free to come down at the very far end and we can answer hopefully any questions that you have.
Brilliant. Thank you very much. A round of applause. Thank you very much indeed. Thank you.